I knew what the Erie Canal was, I remembered the song, and I drove by locks, and I think I knew a little bit about it. Since I've taken this job, I've learned what a tremendous impact it's had on the state. It made New York State the Empire State, but also the country. The Canal Corporation and Erie Canalway run and operate and oversee a living, breathing museum, we feel. It is 57 locks, 524 miles of shoreline. We're on the Champlain Canal right now, which are 11 locks, approximately 65 miles from the Hudson River to Lake Champlain. The first few locks of the Champlain Canal are the Hudson River, so it's a canalized river. And then there is a land cut canal a few miles up here that goes all the way to Lake Champlain. We are at Lock 2 of the Champlain Canal. Not too many folks know that the Champlain Canal actually predates the Erie Canal. The Erie Canal famously began being dug in 1817 and completed in 1825, and since then has been continuously operating in New York State, 3 different versions. The Champlain Canal opened in 1823. So we're on the oldest canal, modern day canal. The Erie Canal in 1825 it was Clinton's ditch. It was a 363-mile ditch. The lateral canals, the Oswego, Champlain, and the Cayuga Seneca were also hand-dug canals at that point. Then they enlarged the canals about 40 years later because of the demand and the people and commerce that were on the canals. In the turn of the century, when Teddy Roosevelt was the governor of New York State, and pressure from the railroads and new forms of travel, he built or began the building of the barge canal. So the third version of the canal system is what we're looking at today. That's the barge canal, and that opened in 1915. So the canal today has really morphed into a recreation way, if you will. Commerce still goes on the canal, but the old towpath where mules used to pull the barges is now a multi-use trail. A canalway trail runs from Albany to Buffalo, and it's 365 miles long. We maintain and operate the trail, but we also keep the canals open and for boats, kayaks, canoes, and people who just want to visit and see the boats come through. It is New York's hidden gem for recreation, tourism, and fun.
This is Lock C2 on the Champlain Canal. There are 57 locks in the New York State Canal System, and each one has a prefix: C for Champlain, E for Erie, O for Oswego, CS for Cayuga Seneca. So this is C2. It's the second one north on the Champlain Canal. Champlain Canal is a little over 60 miles long, and it connects the Hudson River estuary, the tidal Hudson at Troy, with Lake Champlain up north in Whitehall. And boats that travel through the Champlain Canal can then continue on Lake Champlain north, cross the Canadian border, and then descend along the Richelieu River and the Chambly and St. Ours Canal to get to the St. Lawrence River. All of the locks on the canal system are the same length and the same width. So this lock, just like any other, is 310 feet long and 45 feet wide. The lift, the amount that they raise and lower boats at each location varies, anywhere from 8 feet at some of the low lift locks to 40 feet or a little over 40 feet at Little Falls, which is the highest lock on the system, highest lift lock on the system. There are also 2 sets of staircase locks where there are 2 locks connected together like a staircase. They have a combined lift at each location of about 50 feet. So the elements of these locks, these barge canal locks that were built between 1905 and 1918, they have a number of common elements. They're all driven by electricity. Originally, they were all driven by direct current electricity. Some have been upgraded over the years or modified over the years, but typically they were all built to be powered by direct current. And there are some elements within the lock that you'll see at every one. Of course, you've got the chamber, which is made out of concrete. You've got the gates. I'm standing on the upstream gates. There's a comparable set that are much taller at the downstream end of each lock. The gates are made of steel, but you'll notice there's a lot of wood. There are timber pieces that protect the steel gates from boats rubbing up against them. But more important, there are wood pieces that provide the seal. So directly under here, where the water's leaking through, that point where the two gates come together is called the miter. And the seal in the miter is made out of wood, because that seals more effectively than steel-on-steel contact. Similarly, over on the far end of the gate, the hinge point is called the quoin, Q-U-O-I-N, and that also is made out of wood. There's a semicircular piece of timber that rubs against a cast iron lining, and by rubbing a soft material, wood, against a harder material, iron, you get a more effective seal. These pieces have to be replaced periodically. Typically, they're replaced every 7 to 10 years. And there's a sawmill, a special sawmill down in Waterford, at the canal shops in Waterford, and another one at Lysander up near Syracuse, where they mill these curved pieces of oak for the miters and the quoins. As you look down the lock, way a lock works, and this has been this way since the days of Leonardo da Vinci. There's no pumps. It's all done by gravity. You simply open a valve at the upper end, allow the water from the pool above the lock to fill the chamber, and then your boat moves in. When it's ready to go down, they open a valve at the lower end. These barge canal locks are, I won't say unusual, but they're fairly typical of early 20th century design, in that earlier locks, the valves were built right into the gates, and they were called wickets. These locks, the valves are in the blue and yellow cabinets that you see on either side. One cabinet, the one with the 3 lights on top, that houses the valve hoisting mechanism. The other cabinet houses the mechanism, the motors and gearing that open and close the gates. So if we were cycling this lock and we wanted to fill the chamber, the operator would come into the little control booth over there, pull a handle, and start opening the valves. The valves would raise. There's basically a counterweight and a thing that looks like a little railroad car that's hanging vertically in that shaft. As that opens, it reveals the entrance to a tunnel that runs the entire length of the lock, called the culvert. So the water starts to fill that culvert, and then there are a series of tubes along the side that allow the water to flow from the culvert into the lock chamber. The water begins to fill the lock chamber, and it fills up from the bottom. These gates open, boat comes in, grabs a hold of the glide rail or the ropes, or puts a line over the bollards, gets secure, and then the lock operator walks to the far end of the lock. And at the far end of the lock, there's a similar little booth with controls in it. At that end, he opens the valves. At that end, same sort of arrangement. The little valve that looks like a railroad car gets hoisted up, opens up the lower end of the culvert, water goes rushing out, flows from the tubes and from the lock chamber through the tubes into the culvert, rushes out down below, and the water level in the lock gradually lowers. And once the water reaches the same level at both ends, you'll hear a little something. You hear kind of a groaning sound as the pressure on each side of the gate equalizes, and you begin to see a little gap, like you see on those gates now, that indicates to the lock operator that everything is equal, and at that point he can open the downstream gates and allow the boat to pass on its way. again, because this all operates by gravity, it doesn't require a huge amount of electricity. The motors that operate the gates and the valve mechanisms are 7 horsepower, 12 in a couple, but they're big because they're old and they're direct current, but they're not all that powerful, and they don't need to be, because you're simply operating against a fairly simple a counterweighted system in the case of the valves or the gates.
The reason we're here again today is we're going to see a behind-the-scenes look, something most folks don't ever get to see. To my left here is a powerhouse that used to generate the power for the locks. Some of these powerhouses back in the 1915 era generated power for their lock, but they also would heat and light homes and businesses that were in the general vicinity. It was before the grid. The reason why this one is still here is because we're on an island on Lock C2 and we just couldn't knock it down. So I'm going to ask Rodney Haley, our lock chief for the past 20 years at Lock C2, to come out and give us a little tour of the powerhouse and the generators inside. And after that, we're going to ask Albany Engineering to give us a tour of the historic Mechanicville hydro plant.
We're in the powerhouse at Lock 2 Champlain. This is the last fully operational powerhouse that the Canal Corporation owns. By that I mean the governors, the generators, all still are fully functional. These were installed around 1915. They're a 50,000 watt unit. They're paired with a Lombard governor, a flyball style governor. Modernly, nowadays, a governor would sense the voltage and adjust it. These locks were set up at a time when they didn't sniff the voltage. They actually know speed. So a flyball governor is flyballs that move out by centrifugal force, and they're attached on the top and bottom to a shaft on the bottom, which when they fling out, they would move the shaft up and down, which is a pilot valve. So if you were to run the lock and it slowed the generator down, the fly balls would then fall in some and change the position of the pilot valve, which would then open the wickets down below and speed the generator back up to where it belonged. Most of the powerhouses along the Champlain Canal were disassembled years ago, I believe. I'm not sure if it was 50s, 60s, 70s, but the maintenance cost, electricity was cheap. They knocked most of them down. This lock being on an island, which is rare for any lock, the old bridge was rickety and they couldn't get the wrecking ball and crane across it, so it's just the location saved itself. Otherwise, this would probably be gone too. What you're looking at here is a control board. There's 2 generators in this building. The control board, when you fire up a generator, there's a series of switches, old style knife switches that would have to be put in. If you're running, say, generator number 1, of course you have your number here. This would be this way. You would have to put this in and this. And then you would fire up the generator by taking the brake off and getting it spinning. And it would self-excite. By that I mean it would start producing electricity without any further things. When you're going to run the lock, of course you have your governor pumps here. This is the power that would bring it out to the lock. And all these other ones would have been for heat.
So Rodney, you've been working in this lock for 20 years.
Correct.
I always try to tell everybody that, comes across the canal, or when we're talking to the Museum Association or groups like that, the 57 lock chiefs on this system are really almost curators.
Yes.
I mean, it's a living, breathing museum. All of our locks, all of the modern day locks are more than 100 years old. But you really work in a lock like no other. I mean, it's the only working powerhouse left on the system. Is that right? And so,
some of the other ones work, but not everything in the building works. Everything in here is fully functional still.
And they're gone because after a while, when they were obsolete or we didn't need them anymore, we just tore them down to make room.
Yeah, they scrapped all the metal and wrecking balled the buildings. If you go to Lock 1, across the lock, there's what looks like the base of an old building. Lock 3, it's across the lock, and Lock 4 has actually been built into what looks like an observation deck, but that would have been the old powerhouse at the time.
So I'm always amazed, and again, try to give a shout out to the real folks who run this system, right? Run this 100-year-old system. What do you do maybe day to day or throughout your week, for this, for the powerhouse to keep it clean and polished and going? I mean, what did the lock chiefs before you and then you in the past 20 years do to keep this thing running and going and operation?
The powerhouse doesn't require a lot of maintenance except for the water wheel down inside. There's an old wooden bearing that needs to be adjusted to keep it tight. And that was usually done once a year, but because of safety these days, they won't allow us down in the water wheel anymore. So we can't adjust it, so it probably won't really be ran anymore. I mean, maybe briefly, but I'm not seeing it, turning it on if you can't maintain it. Basically, we keep the brass looking good, which most powerhouses, you find out with the hydro next door, there is no brass polish. There's no time to do that. It's running all the time, and the fancy, trying to keep it looking pretty really doesn't happen. That's where Canals is unique. Even the equipment out in the cabinets outside is kept polished and cleaner than most people would do any equipment in the world. I mean, it's kept like a giant working museum. I mean, a museum that's used every day. That's like what you see in here. Basically out here, we keep things painted if we need to. You can see this was all washed down the other day. Within the last 2 weeks, all the brass, everything here, all the brass piping over there was all polished up, which takes probably a day and a half, 2 days out here of just cloths and polishing everything.
And I think that a little later when we go into the Mechanicville hydro plant, you're going to see a tale of two stories, right? Here, we're trying to preserve this and keep it clean and polished and shiny, where over there, they're still making electricity. Right. So there's not too much there's no shine over there, but of course it's as old and
actually older. The hydro there is why we're in the middle of the river. Most locks are on a shoreline. The Mechanicville hydro was put here in around, I think, 1892, and they built over to what then was called Bluff Island, and then the other dam to the other shore. So when they canalized the river in the early 1900s, the best place to put this was to blast into Bluff Island and put the lock here. That's why it's in the middle of a river, basically on an island, unlike most other locks.
I'm Jim Beach. I'm president of Albany Engineering Corporation, and we're at the historic Mechanicville hydroelectric facility, built in 1897 and believed to be one of the oldest operating generating facilities in the United States, if not the world. So this is the southern facade of the plant. This is where the water comes out of the plant. The original facade is in the process of restoration. There were some additions made over the years that are not within the period of historic context. We've taken those off. This square building was actually added about 10 years later to house a steam boiler. They had a steam generator here for a short period of time. It is not within the period of historic significance and eventually will be taken off so that you can then see the entire facade of the building as it was in 1897. The actual building, builder's stone is in that room on the facade. That'll become visible once again. We're going to go inside the plant, and it's noisy. The noise is not from the original turbines. They're very quiet. The noise is from the piece of equipment that we utilize to convert the electricity from 40 cycle power to 60 cycle power. They're called motor generators or frequency converters. They themselves are very old. They're built in 1915, and they were installed originally 20 miles south of here. They were brought here in 1949, and they've been here ever since. They are the tan units as we go in. They're a little noisier. The yellow units are the original units. So when we go in, we're going to be going to the far end of the plant where it's a little quieter, a little further away from the noisy units. The frequency converters are necessary, however, because we can only sell 60 cycle power to the grid, the New York State grid. We cannot sell 40 cycle power. So we generate 40 cycle power, and then we regenerate it as 60 cycle power to sell into the grid. And we tell people we generate twice, but we only get paid once. Well, you'll see that in a second as we go in. These are the original generating units built by the General Electric Company in 1897. We're told that these were manufactured from start to finish in less than 3 months, and were installed here at that time. We'll describe them in detail when we get to the other end. The plant was originally whitewashed. The ceiling, the walls, that's in the process of being restored. Generators are the original generators. They rotate at 120 revolutions per minute. They produce 12,000 volts, 3-phase alternating current at 40 cycle frequency. Everything's original. The bearings in the turbines are wood bearings. The turbines and the generators are babbited bearings. The units are so well balanced that you can balance a nickel on the generators while they're operating. Very solid, cast iron, heavy machinery, and because of that, it's well balanced. These units have been rotating more or less continuously for 120 years. We turn them off every year for a day or two and check tolerances and readjust, but generally they operate 24 hours a day, 7 days a week. There are 6 units operating. There were 7 units originally. In 1930, one of the units had a malfunction of some kind and was taken out of service. We're in the process of rebuilding that unit so that all 7 units will be back in service as they would have been prior to 1930. But 6 of the units I've been operating now for about 15 years at full output, generating power 24 hours a day. The plant makes about 4,000 kilowatts of electricity, which today is only enough for about 4,000 homes, but in 1897 was enough electricity to supply Albany, Schenectady, Troy, the electric streetcar system, and General Electric Company all at the same time. But back then, there was no electrification of homes. Most businesses were not electrified. The main use for electricity was big manufacturers like General Electric and the trolley car system. I should mention the plant today is different than the way it was operated in 1897. 1897, there would have been several operators here, 24 hours a day, manually adjusting controls. That's how electric plants were operated for decades and decades. Today, this plant is fully computerized, and the operator is not here, but he can monitor the plant wherever he is with his iPhone. So after the water goes through the turbines, spins the generators, the water comes back out under the plant and goes back down to the river. The water isn't changed at all. There's no temperature change. We obviously don't add anything to the water. Water comes back out into the river. It goes down to the next site where the same thing can happen at the next generating site, which in this case is the Green Island hydroelectric facility, which takes the same water, goes through another drop, and generates again. The Hudson River has a lot of generation on it. The water goes down through many, many drops and generates a lot of electricity.